Welcome to checking solutions. So recall from a previous video that a solution to a differential equation is simply a function that satisfies the equation. On some open interval. So the general process is essentially the same as checking anything you check in math. So for our process, you're going to find all relevant derivatives of the function. Plug the function and its derivatives into the equation. And then simply verify that the equation holds true. So for our first example, our job is to verify that y equals cosine of 3x minus 2 sine of 3x is a solution to y double prime plus 9y equals 0. So we have y equals cosine of 3x minus 2 sine of 3x, which we will be plugging in. Then we need to find y prime in order to find y double prime. So the derivative of cosine is negative sine, and then chain rule, we would have a negative 3 sine of 3x. Then we'd have minus 6 cosine of 3x. And finding our second derivative, we have y double prime is equal to negative 9 cosine of 3x. And then plus 18 sine of 3x. So this is all of the information we need to plug in. So y double prime plus 9y would be negative 9 cosine of 3x plus 18 sine of 3x. Then we're adding on 9 copies of y. So 9 times cosine of 3x minus 2 sine of 3x, all in parentheses there. And if we distribute it in, this does indeed give us 0 as we would have liked. So we have a solution. Next up, let's verify that y equals c1 e to the 2t plus c2 e to the negative 3t plus 2t is the solution to y double prime plus y prime minus 6y is equal to negative 12t plus 2. So in this case, we'll need y prime, and y double prime. So again, y is c1 e to the 2t plus c2 e to the negative 3t plus 2t. Y prime will be 2c1 e to the 2t minus 3c2 e to the negative 3t plus 2. And the second derivative, y double prime, we would be looking at 4 times c1 times e to the 2t plus 9 times c2 times e to the negative 3t. And then the end would just be plus 0. So if we take our original differential equation, y double prime plus y prime minus 6y, we're wanting to know, will this equal negative 12t plus 2 for our specific y? So y double prime, we have 4c1 e to the 2t plus 9c2 e to the negative 3t. To that, we are now going to add 2c1 e to the 2t minus 3c2 e to the negative 3t plus 2. From there, we subtract off 6 copies of y, so c1 e to the 2t plus c2 e to the negative 3t plus 2t. And we are wondering if this is equal to negative 12t plus 2. If we simplify this, I'm just going to go quickly through. For our e to the 2t, or more c1 e to the 2t, we have 4 plus 2, and then we would have minus 6 copies of c1 e to the 2t. Then for our c2 e to the negative 3t, we have 9 copies, then minus 3 copies, and minus 6 copies of c2 e to the negative 3t. And then for the last bit, we have a 2 and a minus 12t. We are verifying that this is equal to negative 12t plus 2. Well, our first bit is just 0. Our second coefficient is again 0. And that last bit is indeed negative 12t plus 2. And so once again, we do get that we have a solution. This generic form, y equals c1 plus e to the 2t plus c2 e to the negative 3t plus 2t is a solution to our original differential equations. So we will be learning how to solve for these types of solutions later on in the course. Right now, we're just verifying that they are solutions.